Chia. I'm going to present about my research project under supervision of Dr. Evian and Dr. Patricia about comparison of nanocellulose extract from plant leaves. Introduction. What is cellulose? Cellulose can be extracted from plant fiber using some of the chemical and mechanical methods, and they could be extracted in nano and microform by alkalization, acid hydrolysis, and bleaching. Nanocellulose is a term referring to nanostructured cellulose. It is a lightweight material, it has high strength and durability, and nanocellulose is most abundant natural polymer, biodegradable, and completely renewable. It's filler in green composite. Research get large amount of agriculture waste discharged from agriculture industry such as fruit peel, crop stalk, and leaf discharged by the agriculture industry has contributed much to the environment deterioration. Moving towards sustainable world, researchers try to search recyclable and reusable material towards sustainable world. In the study on cellulose, it seems lack of study in comparing nanocellulose extraction from leaf of plants. So in this study, we aim to form nanocellulose from leaf of the plant which are abundant or not useful comparing to their stem, fruits, or other parts. Our first objective for this research paper is to extract nanocellulose from 3 different agriculture biomass such as sugarcane, coconut leaf, and lemongrass leaf. The second objective is to characterization and compare the properties of each sample such as FTIR, UV spectrum, and water absorption. Our third objective is to find out potential application for each sample based on their properties. Methodology of sample collection. 3 different agriculture biomass was collected, which are coconut, sugarcane, and lemongrass leaf, was cut into smaller pieces and dried it for 1 to 2 days in the oven. And the samples was weighed and added for the solvent for alkaline treatment. Homogenization was done to make the cellulose smaller or more uniform. Filter placed in conical flasks. Bleaching was done by added sodium hypochlorite at the sample at 70 degrees Celsius for 2 hours. The sample was washed with distilled water and oven dried overnight at 60 degrees Celsius to remove the remaining lignin in the sample. Procedure of characterization. Sample was go through different characterizations such as water absorbance to determine the amount of water absorbed. Microscope is to characterize the dimension and homogenization of the nanocellulose. UV spectrophotometer is to measure the amount of light that the sample absorbs. And the FTIR is to obtain an infrared spectrum of the transmission. The FTIR, UV spectrophotometer, and light microscope are used for my research project experiment. Water absorption, the equation is cited from Evian et al. 2017. The W is the meaning of the mass of the sample. So the mass of the wet sample is deduct the weight of the dry sample is divided by the weight of the dry sample times 100%. So the water absorption test was conducted by measuring mass of the sample before and after soaking in the distilled water for 24 hours. After soaking, the sample was dried at 60 degrees Celsius in the oven. Now we are going to talk about result and discussion. This is the UV spectrum before and after homogenization, which for 3 different agriculture biomass, which are coconut leaf, sugarcane leaf, and lemongrass leaf. So in the graph, we show that both spectrum change to narrow spectrum, and the peak for each sample are slightly shift to the left with the shorter wavelength. The FTIR spectra of A is represented for coconut leaf, B is for sugarcane leaf, and C is for lemongrass leaf. The absorption peak between 201 and 301 were attributed to the OH vibration of absorbed water. Surface morphology observation. The morphology was carried out using light microscope. For lemongrass, you can see after homogenization, it shows high inlining, so we can expect it to have more crosslink. For sugarcane, after homogenization, we can see the high inlining, but it's not much as compared to the lemongrass. Coconut leaf after homogenization is not as high as sugarcane or lemongrass because coconut leaf structure is harder. Actually, from physical structure of the original leaf, we can observe lemongrass and sugar leaf is softer when compared to the coconut leaf. Percentage of water absorption, it was found that sugarcane has the highest water absorbance reading. The second highest absorbance was lemongrass, followed by sugarcane. Potential application. The property for coconut leaf is hard physical structure and moderate water absorption so that it can be applied to make products that require high shine. The potential application for coconut leaf is skin care, stress relief, weight loss, immunomodulatory effect. So next, for the properties of sugarcane leaf, it requires high water absorption and soft physical structure. The potential applications such as pulp and paper, packaging product, construction purpose, and bioabsorbent. Lastly, for the properties of lemongrass leaf is soft physical structure and easy to blend. The potential application is to relieve pain and swelling, reduce fever, improve level of sugars and cholesterol in the blood, antioxidant, anti-inflammatory. Conclusion. Nanocellulose has successfully been extracted by 3 different agricultural biomass which are sugarcane, lemongrass, and coconut leaf. The property of each type of sample were characterization through morphology observation as DIR, UVB spectrum, and water absorption. Potential application has been identified based on the special property of each sample. Recommendation for further study. SEM or TEM scanning is needed to get a clearer and more accurate result for surface morphology. The potential application of cellulose can be carried out such as biodegradable packaging and antimicrobial materials. That's all for my presentation. Thank you.